Recall the conditions of the containers. Under ideal gas behavior, equal moles of any gas in identical rigid vessels at the same temperature must exert the exact same pressure. Containers 1, 2, and 3 all contain approximately 1.0 mole of gas and exert a pressure of 2.00 atmospheres. Container 4 contains exactly 1.0 mole of sulfur dioxide, so too, mass of 64.1 grams with a molar mass of approximately 64.1 grams per mole, but exerts a slightly lower pressure of 1.96 atmospheres. Understand the cause of real gas deviations. The ideal gas law assumes that gas particles experience no intermolecular attractions. In real gases, however, intermolecular attractive forces, IMFs, exist between molecules. Analyze how intermolecular attractions affect gas pressure. When real gas molecules attract one another, they are pulled slightly toward each other and away from the container walls. This reduces both the frequency and the force of their collisions with the walls, causing the measured pressure to be lower than the ideal pressure predicted by the ideal gas law. Compare the intermolecular forces of the four gases. Helium, He, and neon, Ne, are small, nonpolar noble gas atoms with extremely weak London dispersion forces, LDFs. Methane, CH4, the gas in container 3, is a highly symmetric, nonpolar tetrahedral molecule that also only exhibits relatively weak LDFs. Sulfur dioxide, so too, is an asymmetric, bent, highly polar molecule with a large, polarizable electron cloud. It experiences strong dipole-dipole attractions in addition to significantly stronger LDFs compared to the other three gases. Formulate the final conclusion. Because so too molecules have much stronger intermolecular attractions than the other three gases, they pull toward one another more strongly. This decreases the impact force of the molecules against the container walls, resulting in the observed lower pressure of 1.96 atmospheres. This makes option C the correct answer. The correct answer is option C, have stronger intermolecular attractions than the other three gases.